Good morning, good evening, good afternoon, and thank you for joining Neo4j Live with today's topic, Conversational AI, Conversational Artificial Intelligence with Neo4j and the Unreal Engine, presented by Antonio Origlia. Hi, Antonio. How is it going?
Hello, Alexander. Thank you for inviting me. This is going great here. How are you?
I'm good. I'm good. I'm looking forward to this. I'm very excited. I'm really excited. Yeah, and I know we talked a little bit about this before, and I heard you present this last year at a meetup in Milan. So I know a little bit of it, but it's always great to see. Obviously, what's happened between last year and now. So another half year additional development, I guess, and obviously so the wider world hears about it and sees it because it's, I think, a really interesting and cool application and use case. So it's really cool. I'm looking forward to that. Before, sorry,
I'm happy to be presenting it here.
Yeah, it's good. It's good. Thank you. Before we dive in, I'd like to mention one thing is the Neo4j training series. It's starting tomorrow. So if you are interested in learning a few new skills, expanding your Neo4j graph knowledge a little bit, then you are very welcome to participate in any or all of these upcoming sessions. They are free. You just need to register, so you get the link to join in. Tomorrow we do an intro session with Michael. So if you have not done much with Neo4j or graphs, then this is your stop. Next week, Adam will do intermediate cipher. So if you did a little bit exploring Neo4j and graphs and you want to learn more, then this is a perfect way to go there. And then the other two trainings are a little bit more advanced, I would say, with building a routing application by Will. So it's, I think, a perfect way of get geospatial data and work with geospatial data, and he's doing a great training on that. And particularly interesting is if you watched Michael and I present yesterday on our Aura stream, we had used the newest edition of Neo4j Blue, which is now version 2.7. And this has now the geospatial capabilities as well. And we played around a little bit with that data, and Will in particular had a good time, I think, on that with a couple of tweets recently. So check that out if you're interested in this kind of data set. And then finishing it up in April, Garrett on Spring Data Neo4j. So that's, more advanced Java application development. So yeah, I just wanted to get this out. So yeah, looking forward to this. But now back or actually into the topic of today, conversational AI with Antonio. So before we go into the topic, I guess it would be great if you could say a few words, Antonio, who you are and what you do when you don't tell chatbots what to do.
So yeah, my name is Antonio Riglia, and I'm assistant professor at the University of Naples, Federico II. Good evening to everyone. Nice to meet you all, even in the chat. What I do is work with a team of linguists and computer scientists to develop interactive real-time 3D applications that involve the use of embodied conversational agents. So mainly we do research about how how people manage dialogue, and we try to reproduce the same processes with a theoretically motivated approach. So of course, everyone has heard the buzz around ChatGPT, of course, GPT-3, which is a great technology, but still it has its problems. There are alternate ways to build a chatbot or embodied conversational agents. We adopt an approach that is closer to the linguistics world, because while doing research, we'd like to investigate if we can implement linguistic models in our approaches so that we can exchange knowledge between the two fields. And this is something I will talk about during the presentation.
Cool. what do you think? And maybe we go into this, but it's just a quick question. What do you think is the main difference between your approach and the Chat GPTs, GPT-3, and
So one of the problems with GPT models, but in general machine learning models, is that it's not easy to understand what they're actually doing while they are producing output. So it's very difficult to understand what kind of processes are being activated. Therefore, even from a language philosophy point of view, but not only that, it is difficult to understand if we can trust them to make decisions.
yeah,
The part where you have to implement chatbots or conversational AI in general to provide information to people or to take decisions in general is a very delicate question. In general terms, as we saw around on the internet, GPT-3 models are exceptional at producing naturally sounding text.
yeah,
But in many cases, they can be blatantly wrong. So they can be very convincing while being wrong.
mm,
Even with respect to basic stuff like math, for example, there have been examples of GPT being convinced that 2 + 2 is 5.
yeah, yeah, yeah.
So it's a great technology, really great technology to generate natural language. But still, and this is one of the points I would like to raise during discussion, it's probably better to, at least in our approach, to consider it as one piece of a constellation of artificial intelligence models,
hmm
each dealing with a different aspect of what we are nowadays calling intelligence, although these artifacts are quite far from being intelligent. And actually, Neo4j is one of the tools that we use the most to implement our approach together with other kinds of approaches. Machine learning is one of
Yeah.
these. It's great for perception, it's great for synthesis, behavior synthesis, etc. But we also use Bayesian networks, for example, behavior trees, and I will show you how you can use all these as a constellation, exactly, of systems with the Unreal Engine organizing the work.
Cool. Sounds very good. Yeah, I think it's an important thing you just said. I mean, you talk. I guess you chat with ChatGPT. You begin a conversation and you write something and then they write something back. And you feel like, okay, well, it's like searching something on Wikipedia or on the internet. You know, I ask, like you said, 2 + 2. I want to know what the answer is, and I expect, okay, because I know 4 is the answer. Okay, then 4 comes back is right. Next time I ask, well, what's 2 + 5, and the answer comes back is 8. I assume, okay, is will be correct again, and I don't, you know, think about it anymore. Maybe I don't evaluate again what's happening, and with that is a little bit of the problem
Yeah.
with all of these chatbots in general.
Uh,
It, they need
Yeah,
to,
one possible problem
yeah,
with using them as search engines would be that you would be reading an automatic interpretation of the source text,
yeah,
but not the actual source.
yeah,
So from an informational point of view, it may mask the actual information because right now, when you do a search, you can access the original document and read the original document. There is a potential problem in reading a reinterpreted text from a machine learning model instead of the original material.
yeah, yeah. Yeah, and I think that's what we need to keep in mind, that what this is reinterpretation, and there can be errors and there can be mistakes, as everybody can make mistakes, and then these models are not perfect, and if you just
No
copy
model is
something over,
perfect, yes,
then
of course.
yeah,
So this is the main difference. We try to constrain the role of generative AI in principle to managing the external manifestation of the internal state of the conversational agent. So we try to use them for what they are really good for. So generating very believable text, while the generated text is kept under control from a decision-making point of view by other models that may be more appropriate to leave to the humans the capability to inspect what's actually going on and refer to a theoretical framework that helps understanding, so improving knowledge and keeping things under control when the tasks become more and more complicated.
Yeah, that's a good point.
Okay.
Cool.
So shall I share my screen?
Yeah. Let's do that. And while you're getting ready, always open invite to everybody watching this live. If you have any questions, any feedback, any comment, any remarks whatsoever, type it in chat. We'll be reading it. I'll be definitely reading it, and I'll be reading it out aloud to Antonio if time permits, and if we can go in some kind of conversation about conversational AI, no pun intended, and if we have any time at the end, then we can obviously discuss a little bit. So if you have any points to make, then please do so. I see your screen now, and I get this out of the way, and yeah, looks good.
Okay. Okay, so briefly, I will tell you about the place where we conduct this kind of this research, which is called the Urban Eco Research Center, and it's an interdepartmental research center of the Federico II University of Naples. So it is the ideal environment for people coming from different backgrounds to collaborate on tasks like building conversational agents. In particular, as I was telling you before, we collaborate very strongly with people coming from a linguistics background, but also with architects and art historians. People from the humanities are typically the people we interact with when we develop this kind of approaches, because we like to relate the computational models that we build with theoretical models that have been developed in the humanities field. So in general, these are the interests of the research center. So some brief summary of the topics that I would like to talk about today. First, I will tell you about how we conduct cross-disciplinary research with Neo4j in the field of conversational AI. So Neo4j is a very nice tool for people with different background to share information and collaborate on the same data, whether you want to conduct corpus linguistics studies or whether you want to build a conversational agent. You can rely on the same graph structure, which simplifies communication. Actually, we are quite proud of our linguists here, who are very skilled in the use of Neo4j to conduct their research. Then I would like to tell you about considering Neo4j as part of a constellation of computational models to build conversational AI. And I will tell you about how you can connect Neo4j to the Unreal Engine to develop this kind of embodied conversational agents.
Sounds good.
So in general, sorry?
Sounds good. Yeah.
Good. So in general, this is the kind of work that we conduct at the research center. We start from theoretical models, typically coming from the linguistics domain. These are theoretical frameworks that are built upon the observation of communicative behavior patterns as highlighted by graph structures implemented in Neo4j. Starting from these theoretical models, linguists teach us, computer scientists, about these theoretical models, and we provide a mathematical interpretation of these theoretical models by building computational models, so formal representations of these theoretical models. Our use of conversational AI and chatbots in particular aims at verifying and validating these theoretical models. So we develop small applications, case studies that highlight what is going on, what should be going on from a theoretical point of view. we collect feedback either from simulated users or from real users. We provide feedback to the linguists about what worked and what didn't, so we can enrich each other by collaborating on these topics. So the theoretical model gets enriched by the information coming from the simulation, and the simulation gets better every time that the theoretical model is updated. So we divide our approach, and as you can tell in the lab, there are quite a few fans of a lot of things. So internally,
can always make any word works.
That's true. That's true. So in general,
same
we
here at
divide.
Neo4j, by the way, not with Lord of the Rings,
Really?
but with the Matrix or APOC.
Okay, right, right.
Is a good example of this. Just find.
Actually, I will be using the matrix as one of the example later. So, so in general, we'd like to separate our work into phases. There is the Lorien phase, which means linguistically oriented resources and insights as expressive networks. So our linguists try to conduct corpus linguistic studies using graphs. And the information that they collect into graph databases is then enriched using graph data science, graph analytics, etc., so that we can extract data information from the data represented as graphs. So Lorien is about using data and linguistic knowledge in the form of graphs, so to connect multiple resources. For the movies domain, for example, you can have IMDb, you can have Wikipedia, you can have MovieLens, etc., or a dedicated corpora to people talking about movies, to extract both semantic and pragmatic information. So some case studies, corpus linguistics, communal common ground, personal common ground, personal experience and beliefs. So the question is to understand how people involved in a dialogue, and typically a dialogue is represented as a chain of utterances belonging to different people, is related to knowledge graphs representing the domain. So how are people accessing the knowledge domain? How are they using knowledge domain to conduct the dialogue? And this is mainly the work of Dr. Maria Di Maro. He's one of the researchers here at the laboratory, whose main research interests are related to common ground, dialogue systems, and pragmatics in particular. One of the one of the first experiences that we had with Maria was about detecting conflicting patterns in sequences of commands. This was the topic of Maria's PhD thesis, where we used Neo4j to keep track of what people were telling to a simulated cook robot who would accept cooking instructions. And we wanted to model how the robots would report. This is an intriguing problem because conflicting patterns do not emerge in the moment where the error arrives. They emerge later when a subsequent instruction conflicts with a previous one. So it is important to keep track of the dialogue in the form of graph to be able to go back in the graph as long as possible with paths that can be arbitrarily long, to detect where the cause of the conflict was found in order to generate the correct error message, even from the point of view of the syntactic form, which was one of the other research interests of Maria. So briefly, I will show you this video. Please, Alexander, tell me, I shared the audio, but please tell me if you can hear it. It's a small recording of an interaction with this conversational agent, which was called Bastian. Bastian would continue receiving commands. When there was a conflicting command, Bastian's task was to investigate, to analyze the graph in order to collect the information related to the conflict and assemble an error message. So here's an example.
Sciogli il burro.
Va bene.
Trita la noce moscata.
Va bene.
Mescola la farina e il latte.
Va bene.
Taglia il burro.
Non posso. Burro è un liquido. Non dovevo riscaldare burro?
Did you hear that?
Yes.
Okay. So the problem here was that at the beginning of the interaction, the instruction was to melt the butter, and everything was fine. After a while, I think this was me. I said cut the butter. This was not possible because one of the preconditions of the action of cutting is that the item is not a liquid.
Yeah.
So in the graph, Bastian would have to go back in the history of the dialogue and identify the action that caused the butter to become a liquid, even using the correct syntactic form, which is what Maria taught me is called a high negative polar question. So a question that requires a yes or no answer with a negative form. This is one of the beautiful things about language. The syntactic form encapsulates a complex description of the problem. So Bastian thought that a certain proposition was true, but the collected evidence contradicted what Bastian believed was true, and the entire explanation of why he couldn't cut the butter is encapsulated in a very short sentence, or optimized sentence. This is one of the reasons why it is worth the effort investigating conversational agents from a linguistics point of view. In order to automatically assemble naturally sounding and easily interpretable error messages, it is useful to know that even the kind of form that you assemble is important to help people understand. So besides...
That's a very important point. I mean, with all the error messages, I mean, we here at Neo, we work at with error messages a lot. You know, you type in the query and then you get an error back, and if that error is obscure and you don't know what's going on and why
Exactly.
you don't understand it, then it's frustrating because you don't.
Even in these situations, actually, this is one of the experiments that Maria conducted. People were more able to spot the errors that they committed if the polar question was coherent with the kind of problem that Bastian had to signal. So it is important. People do exploit this kind of structure, and linguists know about this. So we should really make use of knowledge that comes from the linguistics field.
Yeah.
Another important aspect, which is probably the most important topic that we are working on presently in the lab, concerns argumentation-based dialogue. So it's the capability of conversational agents to support their stances with convincing arguments used as support. So in this sense, this is the work of Martina Di Bratto, who is a PhD candidate here at the lab, and her research interests cover common ground, dialogue systems, and argumentation. So the capability, for example, for recommender systems to support their propositions with the appropriate features, supporting features, is important to improve quality of service. This goes beyond providing arguments like most of the people who did this also did that. It's not a very powerful way to convince people. Anyone can ask, okay, who cares about what anyone else did? But if you can, for example, this is what we are trying to check now. If we can understand how more powerful it is to use arguments that come from the interaction, so more personalized ways to recommend recommend items based on the dynamics of the dialogue. This may improve the quality of the service provided by conversational systems used for recommendation purposes. So in general, in this case, we are also trying to develop a graph-based model of argumentation to select, given the history of the dialogue, which are the best aspects of the item that I would like to recommend to support what I'm going to suggest to you. And this is, again, work from Martina D'Imbrato. Another important aspect that we work on is common sense knowledge representation, even in this case in the form of graph. The question here, and this is the work of another PhD candidate of ours, Sabrina Mennella, whose research interests are again common ground, dialogue systems, and common sense knowledge. The question here would be, is it possible to analyze graph structures to derive what common sense is in a certain domain so that we can correctly formulate questions to complete information gaps, to overcome information gaps during the communicative interactions. These are all important aspects that can be described from a theoretically motivated, a linguistically motivated point of view that is reinterpreted in computational terms with a strong support from graph-based representations, given their flexibility and capability to look at the same things at the same time from multiple points of view. So the concept of multigraph is fundamental in this kind of research. So this is in general what we do from the linguistic analysis point of view. I summarize that just because I'm not a linguist, but it pays off to pay credit to the people who do this kind of work for us. Absolutely. Because my domain is this one.
Not an anagram.
So since the linguists live in Lorien, computer scientists live in Angmar. So Angmar, as you can see, I also like writing acronyms.
Yeah.
Artificial neural and graphical models for argumentation-based recommendations, which is the topic that we will concentrate on in the next few minutes. So in general, from a historical point of view, we know that AI passed through different phases. In general, it is important to study AI in the context of dialogue management because it's a very complex task to manage. We know that traditional AI, rule-based, so using logical engines, was too rigid to deal with the real world, and so probabilistic AI emerged and is the most popular kind of AI that is around now. But there is also a tendency towards hybrid AI with the flexibility provided by probabilistic models. In this sense, we try to avoid a one-wins-all approach to model selection. For example, let's do everything with neural networks. And we try to recover what was good about traditional approaches to AI, which also benefit from modern technology. So in this sense, we are maybe closer to an adaptive AI approach rather than to a generative AI approach, because we like the idea of having multiple models available and selecting the right one for the right task, depending on what we have to do.
Okay.
So in general, this is our view. For each kind of process, deduction, decision making, or pattern recognition, try to adopt the most appropriate model. Neural networks are very good at perceptual and production tasks. They are very good at getting rid of all the noise that comes from the real world, which is something that traditional AI always fought with. while higher level processes maybe are better represented by a combination of other models, recovering and modernizing some ideas from traditional AI. For this case, for example, we use, this is our idea, of course, this is our approach to the topic. We have graph databases dedicated to knowledge representation, to deductive reasoning. So path searching can be related to a kind of deduction mechanism, and knowledge filtering. So another problem is that when the knowledge domain is large, it is not always possible to reason on the entire domain. It is sometimes necessary to filter out interesting subparts of the knowledge domain on which to actually reason. Then we have behavior trees, which are another classic approach to AI, particularly popular in digital games. They are good at task prioritization, the synchronization of subsystems, and behavior optimization. So they disable and enable exactly what is needed depending on the situation. For decision making, instead, we rely on Bayesian networks. For decision making, utility estimation, what's the most useful action to perform, given as an explicit goal that is given to the AI. Goal-oriented behavior in this sense is another difference that we may have with generative AI. GPT-like models have a single goal, which is completing the text. They do it very well, but in the end, their only objective is to complete the text. If you make a call at ChatGPT, you're calling a function that is called completion. Instead, long-term planning was one of the strong points of traditional AI. So maybe in this sense, it pays off to try to combine the two worlds so that we both have flexibility and capability of dealing with the real world, depending from machine learning, while the capability of having a longer horizon to look at from other kind of approaches. So in this sense, we use Neo4j graph databases in general to assemble belief graphs to support argumentation. So belief graphs are dynamically built during interaction to represent what the system believes to be true about the user it is interacting with, depending on the results of natural language processing algorithms, so that we can obtain a network of facts and beliefs representing the system contextual knowledge. It can be interesting to filter interesting subgraphs on which to reason to select potential arguments. So in this simple interaction, we have, hello, my name is Jason, are you ready? Yes, I would like to see an action movie. So the intent of this by natural language processing algorithms is a get by genre intent, for example, with the subject action, named entity action, which is also a general item. So the word action is a named entity of type genre, and it is created here. The word action is the same as the concept action genre. The utterance uttered by the user expresses an intent instance. This intent instance is an intent that refers to the named entity action. The get by genre intent has a slot called subject, and the named entity action has been assigned to it by the natural language processing algorithm that we selected. Also, the get by genre intent implies a belief that the user wants whatever has been assigned to the subject slot. So as a consequence of this, a new belief is spawned on the and connected to the system. So from now on, the system believes that the user here wants an action movie because of this intent. If you remember what I told you before about being able to backtrack the dialogue in order to detect the causes of potential incoherence, it is always important to keep track of from where a certain belief came from, so that you can relate it to the dialogue dynamics. So this is one example of how you can use graphs to represent what is happening, the dynamics of the dialogue inside the graph database. And you can use Cypher, of course, to derive information about what's happening and guide reactions from the conversational agent. If we're using graphs to describe the internal state of the conversational agent, we can provide definitions for different configurations of the graph in order to guide the reactions of the agent. So this is how we have divided the possible states of the graph. The graph may be uninterpretable, so it's the first thing one needs to check if the last utterance was transcribed with a low confidence from the transcriber. For example, we can have a property on the utterance keeping track of the confidence provided by the ASR algorithm. If it is too low, the best thing to do is ignore everything else and ask the person to repeat. There may be unknown intents or entities, all these problems that make the further communication impossible are found under the uninterpretable definition of the graph configuration.
Makes sense, yeah.
If the graph is interpretable, it may be incomplete. So there may be missing information to process the user intent. In traditional terms, empty slots have this kind of problem.
Yeah.
If the graph is complete, it may be incoherent, so logical conflicts in the belief graph, which is what we saw before. Then the graph may be coherent but unstable. If there are unanswered questions or open issues, these take precedence on solving the situation. If the graph is stable, it may be undesirable. So from the point of view of defining goals through graphs, our approach is to define goals as patterns over graphs. So an undesirable graph is a stable graph that does not exhibit the goal pattern. So in this sense, the next useful operation from the conversational AI agent is to destabilize the graph to push it towards a desirable configuration. So it's really how the graph evolves behind the scenes that governs, controls the behavior of the agent. And this is something that we actually do explicitly. We separate the behavioral model from the knowledge model so that we can change the graph behind the behavioral model. And if we have an abstract model of recommendation dialogues, by changing the graph, we can also change the capability of the model of the conversational AI to adopt different kinds of, to work on different kinds of domain. Another powerful thing that you can do with Neo4j is that you can exploit the transactions mechanism to simulate a conversational agent that provides hypothesizing mechanisms for what if. In this sense, with using the tools that we will talk about, you can open a transaction in your application and temporarily accept the belief implied by the last thing, an incoherence. If you detect an incoherence, then you ask for clarification and you roll back the belief graph update. So you don't accept the belief. Instead, if everything goes right, you can commit the update and start actually believing. So this is a mechanism to simulate a what-if mechanism in the conversational agent. And it makes use of a behavior tree. So behavior trees are evaluated from left to right. They have meta nodes like sequence and selector nodes. A sequence node succeeds if all its children succeed, while a selector node succeeds if at least one of its children, evaluated from left to right, succeeds. If one node succeeds, then the ones on the rightmost part of the succeeding node are not evaluated. And we can use this to prioritize and organize linguistic reasoning. Now, Bayesian networks. knowledge graphs can be huge. So in the one that we work with, we have something like 18 million nodes and almost 6 billion relationships. Because we have movies, we have movie plots, we computed the embedding of the plots, and we computed the similarity of all the possible combination of the plots, only keeping the ones over a certain threshold, because otherwise it would have been unmanageable. But still, when you want to apply a decision mechanism, you can't apply it on the entire network. One thing that you can do, however, especially if you want to use Bayesian networks, as we said, Bayesian networks are probabilistic graphical models. So they are graphs. So a mechanism that you can do is use Cypher to extract relevant subgraphs and use ontological relationships between the object in the subgraph to dynamically assemble a Bayesian network to take decision. Okay? In this sense, for example, in the movie domain, you can assemble this very simplified Bayesian network. So you have actors, how much people like every single actor influences how much people may like the movie they participate in, and how much. Sorry.
Yeah, that makes sense.
And how much people like movies belonging to a certain genre influences how much people like that genre. So you don't need to reason about everything. You can use Cypher to extract subgraphs and dynamically create a Bayesian network at each step. Then you cancel everything. You ask a question, for example, and you generate a new subgraph, new Bayesian network, new decision, and so on. So in this sense, in the beginning, you don't know anything. So you have this situation here. In the graph, we have information coming from movie lens. So we have data about the population. We can use this as soft evidence to put on movies so that the corresponding distributions are updated. When we ask a question to disambiguate the stance of the user towards a certain item, we collect hard evidence. We can apply this evidence in the Bayesian network. And ideally, when we know everything, we are certain about everything. So asking questions in this view corresponds to collecting evidence to be used in the decision-making process with Bayesian networks, dynamically created Bayesian networks. So this is a summary of the dialogue management approach that we adopt. So during the perception phase, we have machine learning performing automatic speech recognition and intent recognition. We have an internal modeling of the context that we are working on. It is heavily based on graph representations. So dialogue state representation, interpretability, coherence, stability, and desirability checks. Then we have, decision making. Here, embedding-based data filtering is in red because we are trying to introduce it in a more coherent way, but it's not ready yet. We want to use it in a better way than we are at present. Bayesian network assembling, utility-based action selection, supporting feature selection, and then natural language generation, which is the task in which generative AI excels. Then again, machine learning for speech synthesis, and one of the people here who works on speech synthesis is another linguist, a prosodist, and it's Dr. Loredana Schettino. Her work is to work on disfluent speech, while instead nonverbal behavior concerns the generation of body language, etc.
Okay.
This is what happens when we work with this model and we combine it with a generative model. In general, this is the result of a simulated interaction between Jason, which is our conversational agent, and a simulated user. So basically, we produce a very boring interaction based on templates. But then we use generative models to change this. So the prompt is simply take this text and rephrase it. And so we obtain a more naturally sounding simulated dialogue on which we can work on. So the idea is that we can concentrate on the mechanism while leaving generative models the task of making it more appealing, more pleasant, more natural towards end users. So from method to model, we have Lorien from the point of view of the methodology. We have Angmar as a computational model. We need a tool to ease the transfer between the two. And this is what we will be talking about now. It's a tool. It's called Framework for Advanced Natural Tools and Applications for Social Interactive Agents, which is called Fantasia. And this is a never-ending story instead of instead of Lord of the Rings.
Yeah.
And this is its architecture. So the main part is inside Unreal. So Fantasia is a collection of components for the Unreal Engine that allow to connect the Unreal Engine with external AI services, like, for example, things coming from Azure or Amazon, whatever. And here we have the backbone represented by Neo4j. So we have different data sources populating the graph. We have graph enrichment here, and the configuration of the graph here influences what the front end implemented in the Unreal Engine does.
Mm-hmm.
Fantasia is open source. You can download it from GitHub here, and you can access the YouTube channel if you want to look at some tutorials on how to use it, how to install it. Some examples are there about building conversational agents, simple conversational agents with Fantasia. But in general, it's a way to connect Neo4j to the Unreal Engine. You may also want to develop, for example, a VR experience to explore graphs in Unreal. That would be cool, actually.
Yeah, that would be something
You can
else.
do that with Fantasia. It's just a way to allow you to use Cypher inside Unreal and use the data that you get from Neo4j to guide your application. In the past, we have been using Fantasia for a number of tasks. This was 2016, 2017, the first time that we integrated Neo4j with the Unreal Engine, and we used it to dynamically assemble tests for young children to test their capability of acquiring language. It was a coordinated test by the Now robot and the virtual agent. We also used it to control virtual guides inside reconstructed environments, collaborating with the architects here at the Federico II University. So conversational agents that while they were talking, were also able to point towards the relevant parts of the 3D model they were talking about.
Mm-hmm.
And this is something that we are working on right now. It is the Visit 3D project from the Enterprise Logogram that we collaborate a lot with. It's a way to build another virtual guide inside a virtual gallery that goes around the gallery and provides explanations, presentations, and then tries to recommend tours in the Campania regions. This is a regional project. So this is in general what we do, and the tools that we provide, our approach to conversational AI. If you want, Alexander, we can have a short Q&A session before moving to Fantasia.
Yeah, there were two questions in chat. One, I guess you kind of went over those, but we can quickly talk to this. Ravindram asks.
Yeah.
About the code, if you share anything, if anything is available.
Mm-hmm.
So I think we just answered that by giving the GitHub repository in which I posted in chat.
Yeah.
Anything else people should know when they want to try it out? Is everything there, or is there?
No, everything is there. Probably there will be quite a few updates in the next months because some things are changing. We have we know that Microsoft, for example, is shutting down Lewis in the next month. It's moving the technology that we use for natural language understanding in another environment, so we will have to update Fantasia. There will be an update to support Neo4j 5. I've been testing this in the last few weeks, and it looks like it works. So probably this will be the next update. And basically, you can just download it, have fun, If you use it for your scientific research, cite us. It's always nice.
Yeah, of course. And then another question came from Eshwa. When you talk to Bastian, and I guess you explained this a little bit, but when you talk to it and you ask him, slice the butter or something, how is it actually that the bot understands the words? How is the process?
I will show you now during the examples, but basically you open an audio stream towards, now we're using Microsoft Azure, but you can use any service you want. We actually developed the plugin for Logogramma too, to do this kind of work. So you open a channel towards Microsoft, you send audio, and you receive back the interpretation. The role of Fantasia is to integrate, as I will show you in a moment, this process in an easy way in the visual scripting language of the Unreal Engine, which is called Blueprints. So you just connect the dots in the graph, and you behind the scenes it will open the channel, send the audio in streaming, connect to the natural language processing server, receive the answer, pack the interpretation in a Blueprint compatible format, and present it in output. So this is basically what happens.
Okay.
Then if you want to check what happens, then you can submit a query through another node that I will show you now, so that you can call Neo4j and obtain information.
Yeah, okay, that makes sense. And then it basically processes through the graph in terms of, okay, did we already cut the butter, or did we melt the butter? And then we say, okay, process, yes, no,
So
is this possible at all?
The knowledge graph also contains post and conditions for the actions to be executed. So it's just a matter of finding the correct violating pattern between post and preconditions of objects that are the subject of a certain action.
I see. Okay, cool. Good.
Okay. Any other question?
Not for now. I guess everybody is looking forward to the demo.
Okay. Let's then share again the screen here. Okay, please tell me when you see this empty world.
No, looks good. Yeah.
Okay. Okay. First, I'll give you a basic example of how you can use Fantasia inside Unreal. So in Unreal, objects that can be placed around are called actors, and you can define your own actors by using blueprints. Blueprints are a visual scripting language of Unreal, so you can program in Unreal using blueprints. And what Fantasia does once it's installed, it adds components that you can add to these blueprints. So here you can see this Neo4j component, which is not usually available in the Unreal Engine. If you install Fantasia, Fantasia will add this component here. When you have this component, you also have access to functions like this one, submit query. And the same goes for Azure, in this case, the NLU function. So this is a basic example to show you how you can connect the natural language processing technology from Azure or from whatever you want to use in Unreal. So basically, the Azure component has an NLU start function. So I activate it when I press the spacebar in this case, and it will print a listening message. This NLU will raise an event when the interpretation of the natural language understanding is ready. And here's the event that gets fired with all the information that came from Azure in this case. We can get an entity. In this example, the first one, let's assume that we only have an entity. In whatever I'm going to say, I will say something about the matrix, for example. We get this first entity. We extract the string representing the entity. And since Fantasia supports Neo4j parameters, you can build a map inside Blueprints associating the title key to the value of the entity recognized by Azure. Then you specify your query here in the query field, and you can use the parameter title. If you want, you can process this operation as a single request, or you can use the transaction system, as I told you before. And if you need to use transactions, of course, you can pass the transaction ID that you stored from before. When you run this, then when Neo4j responds, another event is fired. And this event contains a series of rows, like a table that you get from Neo4j. And you can access each single row. Each row is composed of cells corresponding to columns. Since these are maps or dictionaries, you can find the specific object that you specified in your query. So I'm returning the released years as year. And after I extract this, I can extract the actual value and print it. Okay? So basically, what should happen now is that if I launch the application here, and I press spacebar, and then I say something about the matrix, like let's talk about the matrix, I should get the year in which the matrix was released, because Azure will isolate the title of the movie as an entity and pass it to Neo4j as a parameter of this query.
Okay. Yeah.
So let's see what happens. Let's talk about the matrix. And then we get 1999. Can you see that in the upper
Top left, yes. Yeah, it's a little
Yes.
bit small, but it's right.
Yes, unfortunately, I forgot to increase the font size. But it's 1999, which is the year in which the matrix came out. So what happened here is that Azure isolated the matrix as a title of a movie. So it provides that as an entity. This is passed to Neo4j as a parameter. This is the query that is run. It gets the year and it prints the year. So pretty easy to set up a communication system between natural language processing and Neo4j using Fantasia. Okay.
Cool. Yeah.
So another round of Q&A maybe before passing to the more complex part. This is just the what you can do if you want to fool around with Fantasia.
Yeah, good question from Cheryl. Should it come back and ask which of the Matrix movies we mean? Because when you say, let's talk about the Matrix, there's like 4 now.
This is interesting, actually. We have dealt in the past with the problem of disambiguating about which entity people were talking about. Because if you think about, we have an example somewhere in papers about Chris Evans. In the movies domains, there are a lot of Chris Evans, not only the very famous actor. But we solve the problem in that case because we perform network analysis beforehand, before using the graph to control the dialog system. If you use PageRank, for example, or the hits algorithm to measure how important every node is in the network, when you have an ambiguity about the name of something, you can realize inside the graph that one node is much more important, even from its PageRank score or whatever any others you can call to ask the question, because there is so much difference in the importance of that specific node in the network that you can assume that people are talking about that specific Chris Evans or that specific movie called The Matrix. So typically we store PageRank, authority, and hub scores as properties of the nodes to disambiguate these kind of situations.
Yeah, and I guess, I mean, this was just showcasing one example. I mean, we talk about conversational AI. I mean, it would ideally would come back with a full sentence, I guess, and then would probably repeat again, say, okay, the Matrix, maybe Matrix 1 or something movie came out in 1991, and then you also know, okay, then you can say, hey, actually I meant Matrix 2 or so. and
depending on your dialogue strategy, you can implement that, but of course you can take this and use an append function to build complete sentences. You will find this kind of examples on the YouTube channel. This is just to show you how to connect the points so that we can get to the more complex model now.
Okay, sounds good.
Any other question?
Not for now.
Okay. So let's move to another situation. Okay, let's save this. And let's also open Neo4j. We can stop this. And while this is stopping, I will introduce you to our friend Jason here. Don't be scared. I know it can be a little yeah, unnerving. As I used to say, he looks like
the eyes.
Yes, it's the eyes. Actually, there is a reason for that, but okay. He looks a little bit like the son of Dr. Manhattan and Cortana, but they both deny knowing anything about him. So. Okay, so let's connect to the JSON database. This is a remote one because it's big. So I can show you what happens behind the scenes of this particular experiment that we are conducting. So while it is easy to have Neo4j connectors inside blueprints, when things get more complicated, we may want to integrate Neo4j with the AI system of Unreal, which is primarily based on the use of behavior trees. And this is the behavior tree that we use for the movie recommendation task. Now I have limited it to only receiving yes answers because I needed to investigate the mechanism of building the Bayesian networks. But I will show you a Python notebook to tell you how this actually becomes a full-blown dialogue. So let's go here. And let's see what happens. First of all, when the application starts, this subpart here is run. And as you can see here, Neo4j immediately comes up. So instead of having multiple blueprints with the management of Neo4j, we created a task in the Unreal Engine dedicated to managing Neo4j queries. We can have even quite big queries like this one here that extracts from the graph the initial substructure that we need to work on when people are not known. We can optimize this a little bit, but still it is quite big. This is why we keep it in another data structure. Inside these tasks, there are blueprints. So this means that every AI system making use of this behavior tree can be equipped with a Neo4j component, and the behavior tree can call Neo4j while performing AI tasks. In this sense, we can submit a query, we can configure in which Blackboard key here the result should be stored. We can define transactions, the timeout, etc. Then we clear the Bayesian network because we need to take a new decision. And we get the default structure of the Bayesian network. And then we initiate the dialogue. And in this case, we will use Amazon Polly to synthesize speech. So this time, in the blueprint managing the conversational agent, Neo4j is present, but only as a component. The system managing natural language understanding and speech synthesis is there, but all the AI logic using Neo4j is found in the behavior tree. This is useful because since we are developing a linguistic theory about dialogue management for the recommendation task, behavior trees, just like Neo4j and the Bayesian networks, are very flexible. It is easy to change the structure of the behavior tree to alter the way in which the AI works, depending on the kind of phenomenon that we want to investigate. In these cases, we also have decorators and observers. So after performing this initiation of the dialogue, so it will speak, it will start waiting here. By using behavior trees, you can define priorities over subtrees. In this case, we use an observer over this variable that signals that the user has said something. When the user has said something, and so a new natural language understanding is interpretation is available, this node here is interrupted by this one, which is on the left side, so it has higher priority, and the logic managing the turn of the system starts. So first of all, we have the update of the graph inside the network here. Okay, so it started. We create the structure that you saw before in the slides to control the intents, and we connect all the things that the people are talking about to the common ground. Next, we start generating the move of the system, and we use the hierarchy defined by Maria about potential communication problems. So higher priority to checking acoustic confidence, yes. Then solving unknown meanings, even for intent and entities. These are all placeholders for now. If you can see here, it's called dummy query for a reason.
I see. Okay.
We need to know that whenever we want to investigate these specific kinds of problems, that's the place they have in the theory that we are developing. Next, we start solving common ground incompleteness. So checking for unfilled mandatory slots, etc. Here we have the subgraph that was controlling Bastian, which has been imported in here. Here we have the commit belief graph, solving a common ground instability, and this will be the place where question answering will be positioned. And this is the most interesting part, which is the part in which the structure that we get from Neo4j is transformed into a Bayesian network. So we have the execution of a cipher query here, returning a subgraph that is coherent with the interest expressed by the user. And for now, we only ask polar questions, and I always say yes just to check how this evolves. When the result is ready, then you get the Neo4j results here. You decide if you want to use the default ones or the personalized ones. You clear the internal data structures, and you start processing the results. First of all, you collect information about the node's authority and the node's hubness, and then you identify target or feature nodes. Target nodes are the ones that you may want to recommend, while feature nodes, so movies in this case, while feature nodes are the nodes that you may use to argument to support your recommendation. So actors, or genres, and so on.
Okay. Yeah.
So in this sense, then you start again processing the results, and I will show you here in the notebook the form of the result coming from Neo4j. We have a table composed of nodes that are in a direct relationship between themselves. For these nodes, we have hub and authority information, whether they need to be median nodes, so they don't have, they inherit the distributions of the parents, a selection of the scores that these nodes had from movie lens, so that we
I think we lost
can
you.
compute the distribution.
Oh, here we go. You're back. We lost you for a
Can
second
you hear
there.
me?
Yeah, now I can hear you again. Yeah.
Okay, so the point here is just that we know that some nodes are target nodes, so they have been chosen because they may be potential candidates for recommendation. And so these are movies typically. So Band of Brothers, The Godfather, The Shawshank Redemption, etc. Very popular movies. While these are features, so Nino Rota, Al Pacino, Marlon Brando, Diane Keaton, etc. Okay.
Yep.
All this information is used here to assemble the Bayesian network. So for each pair of nodes in the subgraph, we create a node in the Bayesian network, and we create an arc between these nodes. So we are practically reconstructing the structure of the graph given back by Neo4j to create a Bayesian network that we can use to reason and to propose new questions or new recommendations. Okay? Then again, we use Neo4j to collect all the beliefs that we currently have about the user, and we use these beliefs to apply evidence on the Bayesian network. Next, we exclude known items, so things that the user already said that he knows. First, we try to exploit. Sorry?
Yeah. This is like the recommendations step is important, right? Because you don't want to recommend something that they already have or
exactly. So you don't reason about that. Yeah. You check if you can exploit, so recommend something. If you decide to recommend something, you can add argumentation. You can add arguments supporting features to your proposal. Otherwise, you try to explore. So ask a question to improve the model of the user. Okay. If you can't do this, then you go back to exploit and you do the best that you can. Okay. So let's keep this open so that you can see it running. Let's put it like this so that you can see JSON here. And let's run the application. Let's see what happens. So this is a bit clunky because I still need to optimize things, but it's good to show you how complex behind the scenes things can get.
Yeah.
Hello, my name is Jason. I am here to help you select a nice movie to watch. Are you ready?
So this is an Amazon Poly voice that is being dynamically altered using the audio engine of Unreal. It's just a playful thing to do. So now I will hit space and I will say yes to say that I'm ready. You should see the behavior tree lighting up in the lower part of the screen, showing you that the actual process is running. So let's see what happens. Yes. Here that goes.
Do you like crime?
Okay, so the Bayesian network has been assembled, and JSON has computed that the most useful question to ask, since it can only use polar question, is to disambiguate my stance towards the crime genre.
Let's see because it doesn't know anything, right? I mean,
yes, in here the point is it tries to disambiguate the most authoritative node, given the HITS algorithm implemented in the GDS library, which is also entropic, so uncertain. So it will try to disambiguate the most important node that it's also uncertain about. So let's see what happens here. I should be able to show you the user here. Oops, no, wrong database. Awesome. Let's go back. Okay, so this is me. And I said yes. Marriage proposals. And this is Jason. So Jason said, hello, my name is Jason, expressing, are you ready? Expressing an intent of checking something. Okay. Yeah. I said yes, and I expressed a confirmation intent. So now he asked, do you like crime? And is waiting for me to answer.
Yeah, okay, cool.
Let's see what happens. Yes.
Do you like drama?
So now it has collected the new information. Now, if we go back to Neo4j and we go back to here, we can see that a belief node has appeared. So now Jason believes that I like crime.
Perfect.
And he can use this path here to look for movies that are related to the crime genre. So it starts collecting new tables instead of the default ones that are coherent with the beliefs it has about me.
Yep.
Now, if I keep saying yes, at a certain point, it should become sure enough about my likings to construct an actual recommendation and choose the appropriate features. So let's see. Yes?
Scusa, Here.
I forgot to put this in in English. Yes.
Here it's collecting. Okay. Yeah.
Do you like action?
And then
Yes.
Do you like young Sherlock Holmes?
Okay, so now he estimated that he knows enough about genres and is trying to look if I like specific movies. Implicitly, he's trying to understand if I like the features of those movies, because he doesn't want to recommend the young Sherlock Holmes. Otherwise, he wouldn't have asked. He's trying to understand if the features of young Sherlock Holmes are something that I may be interested in.
yeah.
So let's go ahead. Yes.
Do you like Miss Bala?
Yes. I don't actually, but still.
I don't even know that movie.
Do you like El Camino, a Breaking Bad movie?
Yes.
Since you like crime, drama, action, I think you may like Polar.
Mads Mikkelsen, not bad. So at this point, Jason decided that he's sure enough to take a stance. He decides to recommend Polar. And since we talked about the genres action, drama, and crime, it uses those arguments, those things that we talked about, to support its proposal. Okay?
Yep.
So this is a way to build a behavioral model that is independent from the domain, because given the same rules for assembling the graph database, JSON can talk about different things. This is what happens from a mechanical point of view. We also have a simulator, separated simulator, to check. This is the one that generated the dialog that I showed you before. So basically what we do is we design the strategies in Python using notebooks. We use simulated users to understand if the strategy makes sense. When we find a strategy that does make sense, then we move it inside this model here, either by developing a new task or a new subtree, a new capability, etc. The advantage is that implicitly, this model becomes a theory, a linguistic theory of how a computational interpretation of a linguistic theory, describing how dialogue management should work for the recommendation task. Everything is debuggable, so I can, at any time, I can go check the configuration of the Bayesian network, of the graph database behind. So here's a whole collection of beliefs that the agent has. And I can understand, we can understand if something goes wrong, why did it go wrong? And we can use it to test linguistic theories. So this is basically the work that we do about conversational AI, but still, as I said before, you can use Fantasia to build a much simpler application.
Now we lost you again.
Even commercial oriented. Oh, sorry.
Your connection.
Fantasia is primarily research oriented, but still you can use it if you want to build commercial applications.
Yeah, of course. Sounds very good. There's one question from Dev Tether. In the Unreal Engine, is it possible to also connect Neo4j with ChatGPT, OpenAI to expand the autonomy of speech?
Not currently, but we actually submitted a project to OpenAI, and we are waiting for feedback because we would like to integrate ChatGPT in Fantasia. We are actually also considering integrating GPT-J, which is the smaller but open source version of a GPT model. So definitely yes, we have been using generative AI, as you saw in the Python notebook, to generate natural language. It is good to have it available in this kind of situation. Yes, so it is in the planning.
Okay, cool. So yeah, I mean, what you need, I think Ashwa asks this is basically the Unreal Engine, and Neo4j. The Unreal Engine is, I think it's available for free. It's a pretty hefty download, but you can download it
Yes.
from the Epic.
Yes, you only have to pay royalties if you earn more than $1 million with your applications, but otherwise it's free.
Yeah, that's the usual system. If you make money with your application, then you need to pay. So yeah, I think that was very interesting. A little longer than the initial time, but nevertheless very interesting. So yeah, thank you very much, Antonio, for the interesting overview, setting the theme, setting the concepts, especially in the beginning. I think that's important. Understand what's going on in this particular case, linguistic wise, and then conversational AI. And then obviously the demo is super interesting. I could look at this for much longer when you see it go through, and then maybe giving it try to make it more complicated. That is always
It's
fun.
a beautiful thing. It's modular, so it's easy to extend.
Yeah. So that would be cool. Yeah, with that, thank you very much, Antonio, for taking the time. Thank you everybody for watching today. Hope you liked this episode. If you did, then please give it a thumbs up and subscribe to the channel. It helps out a lot, so we know what things you like and what things we can do for you in the future with this channel. Like I said, tomorrow, bringing it up again, DevRel workshops starting tomorrow with intro. So that's for you to go if you want to learn some stuff. And on Monday, we have to skip the Neo4j Aura session. So if you were wondering, that is unfortunately had to be skipped. But I'll be back on Tuesday with another Neo4j live stream. This then with Friedrich Lindenberg from Open Sanctions, talking about the beautiful world of financial sanctions on companies and individuals. So should be interesting in these, particularly in these times. So yeah, with that, I wish you all a great rest of your day, rest of your week, and I hope to see you soon. And particularly, thank you very much, Antonio.
Thank you very much for inviting me, Alexander. Have a nice evening, everyone.
Take care. Bye-bye.
Bye-bye.